Okay, let's get this out of here. All right. So 2.3 is about adding and subtracting polynomials. I suppose we're going to, first of all, figure out or address like the title and especially the word polynomial. Like, what are we adding and subtracting here? Polynomials. Well, this might be a little bit of a spoiler alert as far as how this progresses through the notes, but a polynomial is basically an expression. So, I mean, I don't know if there's any significant difference. So let's see how this goes. So a monomial isn't, well, there you have it. There you have it. A monomial is an expression that is a number, a variable, or a product of a number and one or more variables. So again, it's an expression where, like a monomial is an expression, but it's only one term. You know, mono means one or single or whatever, you know, it's basically. So a monomial is a one term. Well, look at this. Here's some examples. So 4x, that's a polynomial, but more specifically, it's a monomial. It's one term of an expression. This is just one term, negative 3xy squared. 7, that's technically a monomial. X to the fourth, that's a monomial. And negative 9, x to the third, that is also a monomial. So there's literally an endless list of possible monomials you could have. But they're all polynomials, but a monomial is the kind of polynomial where there's only one term. Okay. Now some more vocabulary. The degree of a monomial is the sum of the exponents. So the degree of something, it refers to like the power of it, the exponent of it. But the degree of like a single monomial is the sum of all the powers of all the variables. So here, the degree of this monomial would just be 1, because there's an invisible 1 right here. The degree of this monomial, well, this has a power of 1, and this has a power of 2. So the total degree would be 3. The degree of this, okay, see, there is no variable. You could technically say, now you don't need to write this down, but technically you could say there's an x to the 0. It's basically the same thing. So the degree of this is 0, the degree of this is 4, and the degree of this is 3. So again, when there's more than one variable, you add them up. So remember, this degree would be 2 plus 1, 3. Okay, fine. A polynomial is a monomial or the sum or difference of many monomials. So like 2 or more monomials added together. See, there you go. That's a polynomial. You could also just call it an expression. A polynomial that is in standard form, basically the terms or the monomials, they go from like largest degree to smallest degree from left to right. Now, this is where it gets maybe a tad confusing. You could talk about the degree of just a monomial, a separate monomial. You could also say the degree of an entire polynomial. Okay, and basically the degree of the entire polynomial, you just go with the like the leading monomial's degree. So the monomial with the highest degree or greatest exponent, actually, that's I guess I should technically say it like this. The monomial with the greatest exponent, okay, you go with that. But normally, I mean, it's really not that complicated. Like, it sounds like it could get complicated. It normally doesn't. So these, I don't know, it might be a little bit off the video range here a little bit. So here we go. A little more vocabulary, because where are we going with this? well, I don't know. There might be some homework problems that just literally refer back to certain vocabulary words that we're going to reveal here. So here we go. If the degree of the polynomial is 0, we use the word constant. If the degree is 1, we use the word linear. So if there is no variable, if it's just, well, like here's an example. So this has a degree of 0, so we just call it a constant. I think we've used this word before in this chapter. Yeah, I won't get to these boxes until after we do all this, because like this little more has a connection that I'm talking about right now. So if the degree is, let's say, 1, like look at this, 7x to the 1 power. Okay, so this polynomial overall has a degree of 1, so we call this linear. If the overall power, or the highest power, the degree of the entire polynomial is 2, we use the word quadratic, which you're going to see a lot of this in Algebra 2. But so if it's degree 3, like if you have a leading highest degree or exponent in the polynomial of 3, that means the overall degree is 3, and we use the word cubic. So this is a cubic polynomial, this is a quadratic polynomial, this is a linear, this is constant. Now we start to get a little, I don't know, way more rare as far as using these words, and maybe even like working with polynomials with certain powers, but we can use the word quartic for if the overall degree is 4. See, like I know there's like a 1 here, and but remember when it's degree of an entire polynomial, you just go with the highest one. And then quintic. And then there is no word for that, okay? So pause the video if you need to play a little catch up here. Writing this stuff down, copying this stuff down. But I'm going to now switch to other terms that are based on the number of terms in a polynomial. So you can describe a polynomial by its degree, all of these words, constant, linear, quadratic, cubic, so on and so forth. There's also vocabulary words that are based on the number of terms. So this one has how many terms? Just 1. This one has how many terms? 2. Okay? And this one has how many terms? Okay? This one has 3. So maybe I'll stop there so I can go over what the words are here before we move on with the rest of them. Like, that one's going to be 1. You probably already can predict. But, okay. So we've already said this word, haven't we? Starts with an M, because when there's only 1 term in the polynomial, we say it's a monomial. Remember, monomial, one of the first words we wrote down, maybe the first word we wrote down in this video, that means a 1 term that referred to like how many terms there are in the polynomial. What if there's 2? Okay, how many wheels on a, well, what kind of sickle, that, man, I'm butchering this. Let's cut to the chase. Binomial, because, bicycle, there's 2 wheels on a bicycle. That's what I was trying to kind of refer to. Like, give you, so you guys can come up with this without me just telling you. But, wasn't to be. So if there's 2 terms, like here, we have the 7x, and we have the positive 4, those are the 2 terms, so we can call this, because again, they're all polynomials. But if you want to be like pretty specific, you call this one a monomial, this one a binomial. Well, what's a bicycle? But it's not, because it has 3 wheels. tricycle. So we call, when it has three terms, the 3x squared, the 2x, and the 1, we call it a trinomial. So this one, how many terms here? Well, 1. So what do we call it? A monomial. This one has how many terms? How many terms are here? There's 2. The 9x to the 4th and the 11x, both positive. So what do we call when there's 2 terms? A binomial. Once again, they're all polynomials, all of them. This one has 4 terms, doesn't it? There is no special name. Polynomial covers all of it. So this isn't a special name for 4. Remember, this just, all of these are polynomial. But what this means here is in the notes, there is no special name. Like, we don't call it a quadnomial. That's not really a thing. So we're just going to say polynomial because that covers anything. 4 terms, 5 terms, 6 terms, even 1 terms, 2 or 3 terms. How many terms here? 1, 2, 3. The positive x to the 6th, the negative 4x, and the positive 9. That makes 3, so it's a trinomial. And again, all of these happen to be written in standard form, which meant highest degree down, highest exponent and down. Okay, so again, pause the video or go back and pause if you needed to write all that down. But next we're going to get into adding, subtracting, and it's not that crazy. So here we go. So technically the setup here, I mean, when it comes right down to it and you see problems like this, you're just going to see, like, you know, some parentheses. You see a plus sign right outside these parentheses, you know, which technically means a positive 1 out here. Like, you might not actually look at this and go, oh, we're adding 2 polynomials together. You know, this trinomial and this trinomial, we're adding them together. See, we're grouping this together in parentheses for a trinomial, and then we're grouping this one together as a separate, you know, like, you might just look at this and react to, well, there's nothing out here to distribute. You might as well just drop these parentheses, you know. There's no purpose for these parentheses. I mean, if you technically want to say, well, there's a 1 out here, it's invisible, but let's distribute a positive 1. Well, that's going to do nothing. You know, 1 times all this stuff is just going to maintain the same identity. And honestly, same thing here. This is a plus sign, so technically a number that's out here is positive 1. So if you want to actually go through the mental gymnastics of 1 times this, 1 times negative 9x, 1 times 1, essentially you can just drop the parentheses. You know what I mean? And now what do? Well, now you look to simplify, which here means combining any terms that are like terms. Can anything add with 4x squared? This can. Can anything add with, you know, 6x? This, the negative 9x. And then plus 7 and plus 1, you can combine those, okay? And not to risk over-explaining this or over-teaching it, but I don't know. We're doing a bunch of adding and subtracting, right? And if you go back to last chapter where we actually covered order of operations, you add or subtract from left to right, you know. So, well, we got adding and more adding and subtracting. We got to do things. What you need to realize here is that this is a 9x and we're subtracting 9x. But you can think of it as like we're adding a negative 9x. We're adding a negative 9x. So in a way you could think of it as like we're technically adding everything together, but this happens to be a negative 9x. In other words, the sign out in front, okay, matters. The sign out in front is a part of the term. So when we end up doing 6x, with this other one, it's a positive 6x and a negative 9x that are technically being added together. But anyway, let's start with the x squared like terms. 4x squared and plus 2x squared. Oh, wow. Am I really doing that? I guess I am. Anyway, here's what I was actually talking about. I was just, whoa. So 4x squared and 2x squared, that makes 6x squared. 6x minus 9x is negative 3x. And then positive 7 and a positive 1 combine to make 8. And yeah, that would be in standard form, technically. Like you want to probably put your final answers with the highest power first, exponent, and then down, okay, to be in standard form. Next, okay, is an example on subtracting polynomials. See, again, you might not, you might look at this and not necessarily go, oh, we're taking two trinomials, in their own sets of parentheses, and we're subtracting them. We're doing this polynomial minus this polynomial. At the end of the day, you're probably just going to look at this and go, well, I have parentheses here. Parentheses, I have a negative or a minus sign like outside of this parentheses. So what? Technically I have like a negative 1 out here. Like I have a positive 1 technically out in here that's invisible. And if I distribute that, basically nothing's going to happen. You can just drop the parentheses. But here, technically it's a negative 1. And if you, let's actually write this down, these arcs. If you distribute a negative 1, won't that change them up? Yeah. So what's negative 1 times, x to the third? Well, negative x to the third. And then this distributes to the negative 8x squared to make it plus 8x squared. And then it distributes to the positive 11 to make it negative 11. Okay? And then did I really take a step to you could call it commutative property, like rearranging everything because it doesn't matter what order you... yeah, it looks like I did that. But really, I don't know. Even for me, that's maybe a little overboard. But what can anything combine with the 2x cubed? Yeah, the minus x cubed. Remember, and that's negative. Remember, the sign out in front is a part of the term. Positive term, and then we have a term that's negative. So, yeah. So next we have the 5x squared. Can anything combine as like terms with the 5x squared? Yep, the 8x squared. And then we have what? A negative 3x. Can anything combine with the negative? Remember, it is negative. Negative 3x? No. No, there's nothing. And the only thing left is the negative 11 or the minus 11, which doesn't combine with anything. So these combine. Remember, what's 2x to the third minus just x to the third? What's the invisible coefficient out here? Isn't it like technically 1? So 2x to the third minus 1x to the third is just 1x to the third. Remember, technically there's a 1 there, but you don't really write it. And then these combine to be 13x squared. And then nothing else combines. Nothing else simplifies. Okay, the minus 3x is just in your, we simplified it as much as we could. You can't simplify everything together. So this is the final answer. And then this one, just like, I don't know, like another extra example where, again, here there's a 3 to distribute. Here there's like a negative sign or a negative 1 to distribute. So 3 times x squared, 3x squared. 3 times a negative 2x would be negative 6x. And then 3 times 1 is 3. And then over here what we're distributing is a negative sign or a negative 1. So that makes it negative 4x squared. And then, what's technically negative 1 times negative 3x? Positive 3x. And then when you combine like terms, this term combines with this term, and it's minus 4x squared. So positive 3x squared and a minus 4x squared, that makes negative 1, technically. Negative 1x squared. What else combines? Remember, is this 6x or a negative 6x? It's a negative 6x. So negative 6x plus 3x, that's negative 3x. And then this positive 3 or this plus 3 term doesn't combine with anything else, so that's the final answer. And I guess that does it for 2.3. Thanks for following along.